Today we're going to be learning how to rationalise the denominator, but in this case not where it's just a surd on the bottom, but when it's a surd and a constant. This constant can be positive or negative, it doesn't really make a difference here. So the situation we're going to have something like 1 over root 2 plus 1. If you don't know how to do it by itself, have a look at my other video I did the other day, but it's a similar skill but not exactly the same. Before we start this though, we need to know what the difference of two squares is. So the difference of two squares. Not the shape, I suppose you could think of it like the shape, but it's to do with square numbers. So difference is about takeaway, two squares, two square numbers. So we'll say a and b, a squared minus b squared. And what the difference of two squares tells us is that this is always equal to a minus b multiplied by a plus b. This can be proved pretty simply. If we expand this using the FOIL method, we'll get a squared. And then we'll get outside, so a times b. Inside, minus b times a, so that's a minus ab. And then on the last ones, minus b times b, so that's minus b squared. And what we can see is this plus ab and this minus ab are going to cancel off, leaving us then just with the a squared and the minus b squared, which is exactly what we started with here on the left hand side. So we'll have a look at then, how is this going to be useful? Well, we can see if we were to replace not a, but think about if we let c equal to a squared, so a new number c, doesn't matter what it is, but then we know that the root of c, the square root of c, is going to be equal to a. And if we plug these things into our expression up here, what we end up with is that c minus b squared is equal to root c minus b multiplied by root c plus b. Sorry, just making sure I got my letters the right way around there. So yeah, we're going to use this case, and what we can see is this looks very similar to that up there, to that little denominator, and that's exactly why we're going to use it. And where, if you watched my video the other day, we know that we can only multiply expressions by 1, and that we can replace that 1 with a fraction where the numerator and denominator are the same. So we're going to do that again, but we don't want to have exactly the same denominator. We're going to use this other part now, so that when we do the multiplication, we end up with a situation like this. And these things are both integers that are going to be able to, we'll be able to do this and actually evaluate this to find just one simple answer at the end. So let's do a very simple one. We'll do the one we've got at the top there. 1 over root 2 plus 1. So we'll times top and bottom by 1. And instead of doing a 1, we're going to write it as the same fraction. A fraction with the same top and bottom, same numerator and denominator. And you can see here we've got a positive. So what we need to do is pick the other sign. So we just change it to a minus 1. Now we multiply across. Well, along the top, nice and easy, just 1 multiplied by that. It's going to give us the same thing. Minus 2, root 2 minus 1, sorry. And on the bottom then, well, we could write it as the two brackets. We could think of like root 2 plus 1 and then a root 2 minus 1 as two brackets. But we can almost skip that step because we know that when we get these two brackets here, which is now in this form, where c is 2 and b is 1, we can see it's going to be c2 minus b, which is 1, squared. So let's write that out. Root 2 minus 1 over c, which is 2, minus b squared, and b is 1. So b squared, 1 squared is 1, so we'll just write it as 1. Evaluating this then, 2 minus 1 gives us 1. So the overall answer for this thing then, we can say 1 over root 2 plus 1 is equal to root 2 minus 1, as this just evaluates to 1 on the bottom. That was probably the simplest one you'll see. If we have a minus in there, it's the same thing, but this will be a positive in there. You need to make it so that when you get to this situation, that they have the opposite signs, so that you're allowed to use this little rule, the difference of two squares, to get your simplification on the bottom. Let's look at a bit more complicated one, give you another example. Remembering as well, from what I said in the other video, the numerator never makes a difference here. No matter what the numerator is, we do the same thing, should be the same steps to go through, and if it was like 7 on the top now, you would just have everything would be 7 times bigger, so it'd be 7 root 2 minus 7. The denominator doesn't get affected by that. So let's have a look at one in that case. We'll have 5 over root 3 minus 4, so a little bit more fancy. We'll times top and bottom then. by the opposite sign of this. So root 3 plus 4 and root 3 plus 4. So you want to change the sign of the 4. You never change the sign of the surd. Even if this was written as minus 4 plus root 3, it would then be 4 plus root 3. So the root always stays with the same sign. Always stays with the same sign. So let's start evaluate this multiplication. It's going to be 5 root 3 plus 20. But it can be often better to leave it with the 5 out the front for a second, just in case we get a denominator that will cancel off with the 5. So I said it won't make a difference, the numerator. It doesn't. Even if you just left the 5 there, you could imagine the 5 outside the front of this entire fraction and it would still be the same. But sometimes it might help us simplify down later on. So the bottom then, I won't put the 2 brackets because we know straight away that these 2 brackets, when they multiply together, we'll get c minus b squared. C is 3. B squared is going to be 4 squared, which is 16. Evaluating that then, it's going to give us minus 13 at the bottom. So 5 root 3 plus 4 over minus 13. So 5 and 13 don't simplify here, so we can't do anything in that case. But you can see if this was a 15, say, yeah, if we had a root 1 instead, then this would become minus 15 for the 1 minus 16 to give minus 15, and that would cancel off then with the 5. It doesn't happen in this case, so the next thing we can do to simplify this down is we're basically going to, we can either expand the bracket or leave it as it is, doesn't matter too much, but generally we want the negative sign to be on the top. We don't want negative signs on the denominator, we want them on the numerator, so we'll bring that up there. So what we have then is minus 5 root 3 plus 4 over 13. Again, sometimes written like this, minus 5 over 13, lots of root 3 plus 4. No difference there, they're exactly the same answer.